Hi, my name is Arush, and I'm a high school student here from Dubai College. Today, I'll be showing you my music science technology portfolio and one of my projects. So, this project is a Markov chain melody generator, which I've coded in Python. Essentially, you play an input melody, and the system runs a Markov model on it to generate an output melody that's slightly similar but has some melodic variations on it. I think the best way to show it is just to demo it right now. So, I'm just going to share my screen right now. Yeah. So I think now you'll be able to see the software. So this is the UI of the software. I coded this in Python using the Tkinter graphic user interface. So I think I'll just now go ahead and demo how it works. So I've got with me my MIDI keyboard, which is plugged into my laptop. And I'm going to be using that to play my input melody. And that's going to send it to my laptop. Once I start recording, it's going to, pick up on whatever I'm playing on my MIDI keyboard. And once I click stop recording, it's going to send that input as a MIDI file to my Markov chain, which is also coded in Python. That Markov chain is then going to be run on the input MIDI file, and it's going to generate an output MIDI file, which is a new melody that's slightly similar, but also slightly different. The whole point of the system is that it's meant to be a composition buddy. And I'm just going to show you how it works now. So I'm going to start by recording a simple blues melody. I'm going to just pump up the volume a little bit so you can hear the melody better. And I'm just going to re-record it one more time. Okay, now I've finished recording the melody, so I'm going to see what the system actually generates from my input. So let's listen to that now. Yeah, so that's what the system actually generated, which was interesting. It was a little bit similar, but a little bit different in that sense. So I'm just gonna look at the screenshot of what it actually generated over here. So let's see what it generated. And I can play it back to myself. Okay, interesting. So I'm gonna go ahead and try another melody now and see what it generates. So I'm now gonna record my input. All right, that's my input, and let's see what it comes up with now. Okay, interesting. This is quite interesting. So that's what I generated, and I'm just playing it back to myself now. It's taken that same pattern and it's kind of transposed it a little bit. So that's quite interesting. Now we also have these sliders that you'll notice on the left, which we can interact with. So I'm gonna go ahead and up the randomness a little bit and see what it comes up with. It could be a little bit crazy, but let's just see what it comes up with. And I'm also gonna add a little bit of direction bias so that the melody ascends upwards. So let's see what it comes up with now. All right, let's see what it comes up with now. Ooh. Interesting. I think the randomness is definitely having an effect because I can hear a lot of non-diatonic notes here. The start was pretty similar to what we had, and then they started introducing some accidentals like the E flat, the G sharp, the F sharp, and the C sharp. So that's what basically the randomness can do. And it can make it a lot less diatonic, a lot less similar to your original melody. Sometimes it sounds great, sometimes it doesn't. So you really have to play around with it. An important point to note is that the Markov model is entirely deterministic and probabilistic, right? So if you play the same melody to the system twice, your outputs could be very different. One could sound very similar to the original melody, one could sound very different. So it's all to do with probability, and there's no real guarantee. So I think I've shown you a pretty good feature of how the system works. Essentially, you record your melody, the Markov model processes it, and it generates an output melody, which is similar but has some variations on it. You can then interact with these sliders and these control options on your right-hand panel to make something more interesting. In terms of the actual technical sides of it, the whole project is coded in Python. So right now you should be able to see the code. The Python code is on my GitHub page if you want to look at it more closely. One point to note is that the actual audio is being generated by Super Collider, which is a library online. It's an IDE basically. So this code over here, s.boot, basically makes a virtual environment. When I'm playing my MIDI keyboard right now, the sound isn't actually coming from my MIDI keyboard, it's coming from my laptop speakers, and that's done through Super Collider. And when you hear the output melody, which sounds like a piano, that's coming through the Pygame library and playing sound waves from the Pygame library. In terms of actual coding, the Markov chain is all processed in the Python code over here, which I'm just scrolling through right now. And the actual graphic user interface is created using tkinter, which is at the end of the code. Like I said, the full code is available on my GitHub page if you want to go through it. So I hope you found this presentation insightful, and I hope you've enjoyed listening about this project as much as I've enjoyed coding it. Thank you so much for your time today.